We're going to look at kind of what makes a function a function. So, what if something's not a function, right? So we can call things relations to begin with, right? So a relation is just a set of ordered pairs. So here's an example, all right? My curly brackets are atrocious, but that's my curly bracket. I could have 1, 3, 2, 5. I don't know. I could have 4, -2. Maybe that's my. Oh, actually, I want 4 numbers. And how about I don't know. I don't have a 3. So how about 3, 0? Okay. The reason I did that is because there's 4 things here. So we could represent these relations as ordered pairs, as I have them listed here, or we have some different kind of ways to write them. So we could have this table. And typically it's vertical, and the left side is the input, which is typically the x value, and the right side is the y, which is typically the output value. So if I do these numbers, and usually the table goes from least to greatest. So if I go, let's see, I had 1, 2, 4, and 3. So 1, 2, 3, 4. And then I just match up what pair it had. So 1 went with 3, 2 was 5, 3 was 0, and 4 was -2. Right? Another representation we could have is called mapping. So we've got 2 ovals here. Usually we have the input on the left, the output on the right. And we just list our values, 1, 2, 3, 4. And then we list our output values, also usually least to greatest, so -2, 0, 3, and 5. And then to tell which one goes where, so 1 with 3, we just draw an arrow. 2 went with 5, 3 went with 0, and 4 went with -2. Now we could, I don't have it in this example, but what if, doing another color, what if I also had 2, -2? What would that look like? So I'd have 2 and -2. And then mapping wise, I would have a second arrow coming from 2 going to the -2. And then the same could be said if I added one that had the same y value. So what if I did, 5 and 5, right? So I could add that here, 5, 5. I'd have to add a 5 here, and then it could go to 5. Okay. And then we could actually have a graph of these points. I'll graph what I can since this is just the first quadrant. So we have 1, 3. Let's see, I can't do the 2, -2. Let's do 2, 5. 3, 0. 4, -2. I'd be somewhere down here. And then 5, 5. So there's a graph representation. And then we could have an equation. Now, I haven't done the work ahead of time to figure out what equation this goes with. So I'm going to put a star here and say doesn't match our set, right? So this is just a random equation. Y equals x squared plus 2. It's another way we could represent a relation. Okay. So when we talk about these things, we can talk about domain and range. Okay, these are 2 important pieces or characteristics we could have. So the domain is the set of inputs, and most likely they are x values. And then the range is the set of outputs, which is typically the y values. Okay. So let's look at these relations, and then let's list their domain and range. All right. So because these are sets of values, I will do the set notation here, which is the curly brackets that I'm not very good at drawing. So all right, domain is all the x values. So I have -1, 7, 3, and -5. So least to greatest. -5, -1, 3, and 7. And then the range is the y values. So I have -1, 4, 0, and -1. Now, in this case, when I go to write them, I have -1, 0, and 4. I don't need to write -1 twice because writing it one time is going to count for it happening twice. All right, this second one, all right, the domain, that was an ugly bracket. The domain, 1, 2, looks like -3, -1, +1, and again, I don't have to write it twice, and then 2. And then the range is the y value, so 1, 2, 3, -4, -3, 0, 2, and 5. Right? And we can do it from this mapping. So -2, -1, 0, 1, and 2. And then the range 0, 1, and 4. Okay, so even though the 1 is there twice, I don't have to account for it twice. Okay, and I definitely called these curly brackets in that first chunk as set notation. But I'm going to do something a little different, and I guess a little bit more technical for these set notation. So this number 4, so domain, so all the inputs, which is usually the x values, which in this case is left to right. So I have arrows going to the infinities, okay? So actually the domain is all real numbers. So I can do the all real number symbol. And then the range will go on infinitely in the negatives, but there is a top maximum there. So I can do bottom to top. So let's see, we'd go from -infinity all the way up to 1, 2, 3, 4, 5, 6. But in set notation, it looks like this. Still a curly bracket, and then we're denoting the y's. So y's, and then a vertical line to say, okay, it's the y values, and then this is what specifically the y values are. So in this case, everything less than or equal to 6. All right. Let's do it again for 5. So we have a left to right for domain. We're doing the x values, and x is going to be greater than or equal to -3. And then the range would be y. And then 1, 2, 3 looks like -4 to positive infinity. So y is greater than or equal to -4. All right. Number 6 is an interesting one here, right? So we have a little bit of an issue right here. And that issue is called an asymptote, vertical asymptote. So when I say left to right for the domain, I'm thinking -infinity all the way to that x value, which is 1, 2, 3. But then it picks up after that, so 3 to infinity. So the way we can say this is we can say, hey, x values, and then x is everything except 3. So x cannot be 3. And then the range, we have a horizontal asymptote. So for kind of the same reason, right? Like y can be everything but that horizontal asymptote. So we'd have -infinity all the way up to 0, and then 0 to infinity. So I can write that as y, and then y cannot be 0. Let's do a few more. This time we're going to do it with interval notation. So what I like to add in here is the open and closed circles and brackets versus parentheses. So, because interval notation is like if we do -infinity to positive infinity. So we want, when do we use brackets and parentheses, right? So parentheses is, it means it doesn't include the value. So this happens at open circles This happens at asymptotes and at positive and negative infinity. Okay. Brackets is when it does include the value. So this happens with closed circles. And that's it. Just at closed circles. Sometimes it is a little obvious. Like I'm just going to look at 12 right now. That right there is a closed circle. But a line, right, is actually just an infinite amount of closed circles. And that's how it's like connected. So yeah. All right. So for this example here, it's a little bit cut off. Let's say, I don't want to put an arrow there, that the pattern is continuing. It's like a sine function here, right? So the pattern is continuing. So that is what I'm going to call this weird symbol. The pattern continues. Okay. So the domain is going to be all real numbers. So negative infinity to positive infinity. But then the range, it caps out here. And that's going to be from 1, 2, 3, 4, negative 5, all the way to 1, 2, 3, 4, positive 5. And that value is included. So we're going to put brackets on both because they're included on both. All right. Okay, so on number 8, I have an open circle here. So that means x cannot be equal to, and sorry, it's my dog in the background, x cannot be equal to negative 1. But with interval notation, we want to write it like this. All right, we can go from negative infinity all the way to negative 1, and then I have to lift up my pencil. And then I can continue on. I've lifted my pencil, I've skipped negative 1, and then I'm going to continue on. So negative 1 to infinity. And then we can use a union symbol here. It looks like a U to kind of connect these two together. And then the range here is 1, 2, let's see, y cannot be negative 3. So we can do kind of the same deal here. So negative infinity to negative 3, and negative 3 to positive infinity. All right, let's look at 9. So domain is left to right. So negative infinity all the way to here, which is 0. It's included because it doesn't denote a open circle or an asymptote. So it's a bracket. And then the range is negative infinity to positive infinity. All right, let's keep going with some more. So domain here, we don't have any issues with any kind of vertical asymptotes. So negative infinity to positive infinity. Sorry, my infinities are getting atrocious here. And then the range, it does look like we are bottoming out here at a horizontal asymptote. So we're going to go 1, 2, 3, 4, negative 5, all the way to positive infinity. All right, and then here it does look like I have a vertical asymptote. So let's see, x cannot be, was that negative 1? So negative infinity to negative 1, and negative 1 to positive infinity. And then the range doesn't look like there's any issues. We don't have any horizontal asymptotes. So negative infinity to positive infinity. All right, with 12 here, I've got an open circle and a closed circle. So left to right, 1, 2, 3, 4, so negative 4. And then that is an open circle there. The x cannot happen there, so parenthesis. Then all the way to 1, and that is included, so a bracket. And then the range. First thought might be to say there's an open circle, so 1, 2, y can't be negative 3. But if I follow the graph, look right here. Wouldn't that be a y value of -3, right? So I can be -3. So I can't say that it can't be. And so then we're bottom to top. So 1, 2, 3, 4, 5, 6, 7. So -7 all the way up to 2. All right, so the next thing we're going to look at is what's the difference between a relation and a function, or what makes a function. So a function is actually just a subset of relations. Relations is like the big umbrella, and then functions is a specific type. And so the defining feature of it is that your input values cannot repeat with a different output value. So to fill in these blanks here, so a function is a special type of relation in which each element of the domain, right, so that input value, is paired with exactly one element of the range, or the output values. So we do not want to have same x value twice, right? So let's look at these relations here and determine, are they a function or not? So I only need to look at the x values. So -3, -1, 2, and 5. They do not repeat. So this is a function. Let's look at this mapping. So right here, I see that -9 is mapped to -2 and 5. That's what cannot happen. I cannot have an x value that has two different outputs. So this is not a function. All right, 15, these ordered pairs. I only need to look at the x values, so -7, -5, -2, and 0. Those don't repeat with different y values, so yes, this is a function. But notice, we have y values that are the same. That is okay. Totally okay to have the same y value. Not okay to have the same x value. If we have a graph, this is one of the easiest ways, I think, to tell something is a function or not, because there's something called the vertical line test. So if we can't have x values that have two different y values, think about what that looks like on a graph. You know, if I have the points, I don't know, 1, 2, and 1, 5, right? That could look something like this, here and here. So we wouldn't want to see two values in the same vertical line. So what we can do is we can say, hey, I'm going to draw vertical lines and cross the entire domain. And if it hits twice, then we're not a function. So I'm going to draw, see, I'll just draw it in red maybe. Okay, here's a vertical line. We pass once. All right, this is me drawing as many, an infinite amount of vertical lines. And we're seeing if it hits twice at any point. You could also think of it as like holding your pencil or pen, writing utensil, in a vertical line and then dragging it across the graph. So it's kind of what I'm trying to model with drawing these vertical lines. But in this first one, I can go all the way here. And yes, this is a function because we don't hit the vertical line twice anywhere. But in 17, right, I could draw this vertical line right here, and I'm hitting once here, and so automatically not a function. Doesn't matter that it's happening everywhere besides that vertex. If it fails once, it fails. So, all right, we can try again with 18, all these vertical lines, and it doesn't look like I have any issues. So yes, this is a function. All right, and that is all for this section. So if you have any questions, let me know.